Now that you've mastered pilotage, we need to discuss another form of navigation. There are many times on a cross-country flight when you can't always keep landmarks in sight. There are only so many Sears Towers and Mount Shastas on the planet, folks. So what do you do besides cross your fingers when you're flying between landmarks? Well, the answer, my friends, is not blowing in the wind. The answer is the way to navigate from one point to another, especially one you can't see until you get close, is called DR. No, that's not DR as in doctor. That's DR as in dead reckoning. Yeah, I know that sounds kind of negative, but it's really not. The word dead, D-E-A-D, really evolved from dead, D-E-D, or an abbreviation for deduced. And deduced, as you know, is the definition of when you play a card game, for instance, like fish, and someone takes all your twos, well, then you've been deduced. Well, this is all very well, but what does dead reckoning mean to you? Well, for one thing, it means a more efficient mode of navigation than flying from one major landmark to another. Good visible landmarks don't always lie in a straight line, especially in the direction you're heading. Dead reckoning also means that you'll get into your airplane knowing what heading you'll be using between checkpoints, how much time you'll have between checkpoints, how long the trip will take, and how much fuel you will use. So, how do you DR your way around? Well, you'll begin your flight planning by selecting checkpoints for your route, then measuring the course distance and direction for each leg. For the purposes of dead reckoning, checkpoints are readily identifiable features over which you can record the time you passed that checkpoint. Now, by the way, there's a trick to selecting those checkpoints. Your purpose is to record a time over a fix. So your checkpoint must determine a point, not an area. A lake is not a good checkpoint, but the shore of a lake might be. And your checkpoint must be one that you can distinguish easily from others. All road intersections tend to look a lot alike, but the intersection of a road, here's a road, and a railroad is much more distinctive. Next, you'll work your wind problems for each leg so you can determine the wind correction angle and your ground speed. And it's important to do this for each leg because your course may change, as well as the forecast winds along the way. Next, you'll take those ground speeds and work time problems for each leg. Then you'll use the times to find out how much fuel you'll burn for each leg. Then you'll add up the times and fuel for individual legs and then total them for the entire trip. And finally, you'll take the courses and wind correction angles to determine the compass headings for each. And when you're done, ta-da, you've deduced how to get where you want to go and how long it's going to take you to get there. Dead reckoning, then, is navigating by computations based on airspeed, course, heading, wind direction and speed, ground speed, and elapsed time. So when do you use DR? Well, the answer is all the time. It's an integral part of planning any cross-country flight, even if you use electronic aids for course guidance en route. DR calculations are essential for helping you find out if you have enough fuel for a trip. Usually, you'll navigate by combining both dead reckoning and pilotage. You'll fly your course based on DR, then make continual small corrections if you find that you're drifting off course. For example, if you see a distinctive riverbed on the right of your course, when on the chart it's supposed to be slightly left of your course, you'll know that you're left of your desired course and will need to correct to the right. Now, you will use your time calculations to tell you when you should expect to be somewhere. When you begin the flight, you'll note the time you departed and add it to the estimated time en route, or ETE that you calculated to the first checkpoint. This will give you your ETA, or estimated time of arrival, or when you expect to actually reach that checkpoint. When you're over the first checkpoint, you'll note the actual time that you arrived. Then you'll repeat this process for each subsequent checkpoint. Knowing when you expect to arrive at a checkpoint makes it much easier to identify it, because you'll know when to start looking for it. If you find that you're continually early or late at your checkpoints, you can adjust your calculations to compensate. And just where do the differences in headings and times come from? Well, they all come from the actual wind being different from the forecast wind, since you'll always be dead accurate calculating your DR. And you'll also find that through use, the DR could also be called darn reliable.